All right, this is lesson 2.1, check for understanding number 1. The question says, for each of the graphs below y equals f of x, sketch the graph where y equals the square root of f of x, and state the domain and range of the square root of f of x. Well, remember that f of x is essentially saying what is y, and we're going to take the square root of the y values. Okay, so I've set up a chart with the original values as well as the transformed values. First graph here, A, -2, 0, 0, 4, 1, 6, 2, 8 are the points I picked. Nothing is happening to the x values. X remains the same, but the y values, we must take their square roots. So a lot of the times you want to pick values where the y value is a perfect square, which will make the square rooting step quite a bit easier. So notice here, I'll move my gray bar. I have taken the square root of the y value, square root of 0, 0, square root of 4, 2, square root of 6, 2.4, and square root of 8, 2.8. And we might as well take care of both graphs at this point. So once again, I have the coordinates 0, 3, 2, 2, 4, 1, 6, 0 picked. X doesn't change, and y must become the square root of those values. Okay, so we'll need to plot those points, and remember what happens to the graph when you take the square root. So just off to the side here, you'll remember from the previous unit that a bending ray is what the result is of taking the square root of x. So let me try and draw that as best I can here. This is our parent function for square root of x. Remember the bending ray? It looks like that. Y equals square root of x. So when we take the square root of the y values, that trend will also continue. Okay, so let's plot those points. So let me pause this first. All right, so let's plot these points. So what do we have here? We have -2, 0. Remains the same. We'll put a big circle above that. We have 0, 2 as a new point right there. We have 1, 2.4, 1, 2.4 right there. And what's the last one? 4, was it 2, 2.8. 2, 2.8. Whoa, no, that's not right. 2, 2.8. Yeah, that's right here. Okay, 2, 2.8. So notice that that bending ray trend seems to be taking place here as well. And one thing you'll want to notice is, well, what happens over this part of the curve here where it starts at -2? Will it go above the red line or below? Well, you're going to find out that for this one, that bending ray actually will normally travel above the original line and then cross over. So it'll look like that. I'm drawing that with my mouse, so it's not so easy, but you got the points marked perfectly there. So that's what that function would look like. With the second one, let's label those points. What do we have? 0, 1.7. 0, 1.7 is about right there. 2, 1.4. 2, 1.4, roughly there. 4, 1. 4, 1 right here. And then 6, 0. 6, 0 would go right over here. I need to draw one more circle here. There we go. 6, 0 here. So once again, the bending ray goes to the left for this one clearly. So the curve travels above and then coincides and gets flatter and flatter as it travels through the y-axis like that. Make sure you put an arrow on the end. Okay, so we're now ready to state the domain and range. For the first one, let me put this down to one single page so it's a little easier to see. Yeah. So the domain, notice that x for this one can be anything bigger than or equal to -2. So we say x is greater than or equal to -2 because it goes to the right. The range, y can be anything bigger than or equal to 0 for this question. And the second one, the second graph, where are you now? Oh, down below, sorry. Here we go. Whoops. There it is. For this one, the domain x is less than or equal to +6. That's the starting point. And y is greater than or equal to 0. Okay, hope that worked out well. Make sure you pause the questions so you have a chance to try them, and then check your answers. Why don't we go back to the solution here just to make double sure that we got it right. Yeah, everything looks perfect. Okay, good luck with example 2.